Navneet, from next week we are transferring to 5:45, correct?
Yep, right.
Okay. I will inform everybody so that there's no confusion.
Yeah,
Pranav, from next week we are transferring to 5:45, correct?
Yeah.
Okay. Anya, Sahana, from next, oh, 5:45 means you cannot attend, Sahana. When are you coming back, Sahana?
Yeah, so we're actually coming back on July 22nd, I think. So I'll have one class.
One class in the morning, huh? Oh my God. Okay. I don't know. Do we want to continue the same time then next week? Or do
Yeah.
you want to watch the recording? Sahana, you have to tell.
Um, I guess if everybody, I guess I can
Okay, I'll talk to your
join.
mom. I'll talk to your mom. Okay.
Okay.
I'll talk to your mom, otherwise I'll help you separately. Okay, I'll talk to her. Harshika, from next week, can you do it at 5:45?
I can't because I have a class 6 to 7 every Friday.
You can't? But we did
No.
discuss this earlier, right, ma?
I didn't come to the last class, and I think my mom said she would talk to you after reading the email.
Till when do you have that class?
Um, I think for at least 2 months, maybe.
Oh my gosh. Mm. Okay, then we need to talk this out, lady, because see, I think we have already emailed out the times, right? It will switch, na? We did discuss
Yeah.
this in the first class as well, second class as well, right? Every time we keep discussing. So let me talk to your mom on that. Okay,
Okay.
guys, then I will provide an update on the timings. Don't worry, okay? In the WhatsApp group, please join the WhatsApp group if you have not. Okay? That's my humble request. Make sense, guys? I'll definitely provide an update. I will remind you about any changes in the times as well. Don't worry at all. Okay? But please join the WhatsApp group. Okay? Okay. How was the homework? Did you have any questions? Did you have any questions, guys? Okay. Avni, did you have any questions? If I don't call you by name, you not I don't get answers. Did you have any questions, Avni?
No.
It was easy, right?
Yeah. I didn't submit it, but I went through it.
Went through it, okay. Okay. Anya, Pranav, Harshika, how was the homework? Please, videos, guys. It's important to have that thing.
Um,
Abhi, were you
my
able to? Uh-huh.
my camera isn't working.
Okay, no worries. Okay. Shikhar is coming. Okay, so let's see, where are we in the class? Did the polynomial intro, right? Uh-huh. Navneet, did you have any questions, Navneet, there?
No.
Akshada, did you have any questions?
No,
Are
I
you
didn't
going,
have any.
are you going through the answer keys, guys, to check whether you're getting it right? Akshada, did you check against the answer key, ma?
Yeah, I did.
That's nice. Okay. Pranav, you're going through the answer key?
Um, I haven't, like, sometimes I do. Just check my answers.
Yeah, please go through the answer key every week. Abhiram, are you doing your homework?
Yeah.
But you've not submitted, right?
I haven't submitted it, really?
Yeah, at least the previous week I did not see. And Mahir, are you here? Yeah, Abhiram, I don't see it for the week of, which week is this? That's what I wanted to check with you because I had written some notes based on when I went through the homework, I had some notes written down. So clearly, no, you have not submitted at all. I can check separately. Shrikar, how is it going for you?
Good.
Yeah, and who is this Who is this in the classroom? Okay, that's scary. I don't know who is this You should have proper names. And Shrikar, you have joined the classroom, huh?
Yeah.
I'm so confused, guys. Oh, yeah, you have joined in a different name. Okay, that's fine. Sahana, did you have any questions in the homework?
I didn't get a chance to do it because I just watched the video like
Oh,
last
yeah,
night,
yeah,
1
it was
a.m.
because of me. I know. Okay, sorry. Okay, that's fine. Let's get going. If you don't have any questions till polynomial intro, we can get going. But I'm going to conduct another test on 1.3 to maybe 1.5, whatever we finish today. Makes sense? Can we move on? Okay. Let's see. So we have done we did polynomial functions and rates of change. Correct, guys? Is that right? We did polynomial functions and rates of change last week. Correct. So let's get into I need to work on polynomial functions and complex zeros this week. So let's see what is in there. Okay. Okay. We did discuss point of inflection. We did discuss even degree, absolute extrema. Okay. Absolute extrema. We did discuss absolute max, relative max. We did discuss. Okay. Let's go ahead with the complex zeros of a polynomial function. Let me share the screen. Mahi, did you join, Ma? Oh, she's not joined yet. Okay, that's good. Okay, let's see. Zeros of a polynomial function. Okay, so the first unit basically is going to be all polynomial functions. Okay, the second unit is going to be all about rational functions. Then we get into exponential and logarithmic functions. After that, we'll go into vectors, polar graphing. Okay. So the first definitely 2 units will be easy, and then exponential and logarithmic will be very easy if you still remember. Then we get into trigonometric functions. Trigonometric functions is when it opens up a lot of new things. Okay, that gets into polar graphing as well later. Okay, so let's go ahead. Let's see this one. Okay. Let's say there is a polynomial function p of a. Okay. Okay. Now, suppose if we have p of a will be equal to 0. What does it mean? Meaning, what does it mean? A is called what? A is called what?
A
Suppose, see,
zero.
A is called a 0. A is a 0 or x-intercept or a root of the polynomial. Make sense? Okay. Now, okay. There are more inferences. Okay. Okay. Now, we can as well say we have an x-intercept at which point? At which point? What is the point? If P of A equal to 0, let's say consider f of x, okay? Like f of x can be any polynomial. It can even be a quadratic function, right? Now, if this is equal to 0, then we say, let's say, when I say, okay, for some value of x, this f of x, y value is 0, right? Then we have the x-intercept at which point? What is the coordinate point of the x-intercept?
A comma 0.
Yes, a comma 0. Nice. And then suppose a is real number. If a is a real number, then I can say x minus a is a linear factor of the polynomial. Does it make sense, guys? Does it make sense? Okay, now this is a nice example to deal with. I can write this out as x plus 2 the whole square. So I can say f of x equal to x plus 2 times x plus 2, correct? Now, what value for x if I put? My y value becomes 0. When x equal to minus 2, my y value becomes 0. So that I can call it as the x-intercept or 0 or root of the polynomial. What is my x-intercept? Minus 2 comma 0. See, a is minus 2 here. So a is definitely a real number. Minus 2 is a real number in this case. So what can I say? See, x plus 2. X minus a, right? X minus of minus 2. A was minus 2. So x plus 2 is a linear factor of the polynomial. Any questions? Easy one, right? Now let's see. How about this? Okay, this one you're going to find for me. Let's see. Okay, let me see whether you can plot it as well. X cube minus 2x square minus 8x. X cube minus 2x squared minus 8x is my f of x. Can you graph this polynomial? Graph this polynomial. Show the x-intercepts clearly. Would you be able to do that? X-intercepts and n behavior clearly. Guys, if you can't do it, please message me. That's absolutely fine. I just want to know how many of you remember, how many of you don't. If you don't remember, it's my duty to help you. But please let me know. Go ahead, guys. If you don't know as well, only when you let me know, I will be able to help. Let me know, guys. If you don't know as well, you have to message me. That's the only way for me to know. I am thinking you know this, that's why I gave you. But if it's okay, if you don't know, that's absolutely fine. You get it? Yeah, I got 3 answers. I didn't get anybody else. Abhiram, how many roots are there for this polynomial? I think you got it, but how many roots are there for this polynomial?
All 3.
3, but you have written only 2, right, Amma?
Oh, I forgot.
You forgot about the third, okay.
Yeah, I forgot. Yeah.
Just send it to me, no problem. Yeah, that's right, but the third one is incorrect. Yes. Pranav, good job. Pranav, is the signs correct? Akshada, is the signs correct? Yeah, Harshika. Hey, Harshika, just message me which grade are you in and when are you taking the SAT?
Should I message you?
Yeah, message me. I just want to know because you seem to be prepared for most of the questions. Okay. Abhiram, that's correct. Sai Shrikar, that's good, Amma. So here, okay, there are some of you have said that you don't remember how to find the roots of the polynomial. Chetan, we have written the polynomial x cube minus 2x square minus 8x on the board. We are trying to find the x-intercepts of the polynomial. The polynomial reads f of x equal to x cube minus 2x square minus 8x. In this case, I'll take x as common and then say x square minus 2x minus 8. Now, this is just a quadratic function, right? How to factorize it? What are the factors of 8? I would say 4 and 2, right? So I can factorize it directly. Minus 4x plus 2x minus 8. Now x, and then here I'll take x as common, x minus 4. And then I'll take 2 as common, x minus 4. Now x is outside. Then I take x plus 2, then x minus 4. So this is the factored form of the polynomial. Now, how do I graph the polynomial? X 0, x equal to 0. See, each one can be by zero product rule. You can make this equal to 0 and find out all the zeros. When you equate it to 0, either x has to be 0, x can be 0, or the 0 can occur at minus 2, or it can occur at plus 4. So at 3 places, the graph will cross the x-axis. They are all real zeros. 3 real zeros, right? So this is cubic polynomial, so it has 3 roots. The leading power of x is 3, so it has 3 roots. Now, if it's a cubic function, how is the end behavior? That only will help me graph the polynomial function. It's a cubic function, so for a I'm taking... I see. Okay, Harshika, thanks. So now, since it's a cubic polynomial, how will a cubic function be? The cubic function is like this, right? I'm lost. Okay, remember, let's move on from quadratic function. A quadratic function goes like this, right? This is x squared. This is minus x squared, correct? So for a cubic function, what do we do? Let's see. Cubic function. This is quadratic. For a cubic function, I'll go ahead and do something like this, right? See, it cuts the x-axis at 3 places. The quadratic function actually cuts the x-axis at 2 places, but then this is a U-turn, right? So that's a repeated root there. Now, x power of 4 will be like this. The end behavior. How do I say the end behavior? Like this and this. Guys, are you having any questions? Then you have to ask me right now. Cubic function end behavior is this and this, meaning when it goes to minus infinity, x goes to minus infinity, y goes to minus infinity. When x goes to plus infinity, y goes to infinity. For a quadratic function, the end behavior is written like this. Navneet, are you following? Okay. Now for this function, let me write out the end behavior. It's a cubic function, so something like this, right? So it goes like this. Now, how do I plot the graph from somewhere? See, this is the direction, right? End behavior. So it comes like this, goes like this, goes like this, and then connects you. Make sense, guys? You just need to connect and find out. Now let's go ahead. So we showed the x-intercepts and behavior and graph the polynomial. Now let's go ahead and try this one. We should be able to graph any polynomials that's given. So now I really want to be able to. Yeah, I have it in here. Let's see. Can you graph this? This one is an easy one. It's more of a quadratic function. So go ahead, graph it. Please show me the graph. Send me the zeros. And how do you decide? Let's see. How do you decide the... Yep. How do you decide the end behavior? Okay, let me ask you. Tell me, yeah. You have to answer the question. Okay, first of all, graph the polynomial. And then what part is h of x is greater than or equal to 0? I'm reviewing, guys. So if you don't know, it's absolutely okay for you to tell me that you don't remember it. Make sense? Did you get it, guys? Uh, Avni, did you get it, ma?
Yeah, I'm typing my answer.
Uh-huh. Akshara, do you have the graph with you?
Yeah, I can show you.
1 second, ma. Let me check. Okay, good. Okay, you want to show me? Show me. Yeah, these are easy ones, right? That's what I'm thinking at least. I don't know. Yeah, ma. Thanks, ma. Do you know how to write the domain in interval notation? Do you know how to write the domain in interval notation, ma?
Yeah.
Or just answer the question. What are all the intervals on which h of x is greater than or equal to 0? That's what you're going to send it to me. Pranav, you're not on the video. Mahir, you're not on the video. A lot of previous year review, right? Avni, did you get it, ma?
Yeah, I sent my answer.
Oh. Akshada, is that right? To infinity. Harshika, that's right. Shrikar, that's right. Yes, Abhiram. Yeah, guys. Akshada, you just interchanged it. So basically, see here the zeros would have been at -1 and 3, right? -1 and 3, right? So these two are the zeros, right? And it's a square function. So basically there is no negative, so it has to face up, right? Because the end behavior is like this as well. So h of x is greater than 0 means, see here the function can be split into interval 1, minus infinity to this point -1. Then the second interval is -2 to 3 and 2 to I'm sorry, 3 to infinity. So that's the third interval. You know, h of x is greater than or equal to 0. Remember from algebra 2, I just want to review how do we do this. So we can have intervals, right? Minus infinity less than x is less than 0. I'm sorry, not -1. This interval. And then -1 is less than x is less than 3. That's the second interval. Then what is the third interval? 3 is less than x is less than infinity. So here sine of f of x. What do we do for sine of f of x? Plug in any value in this interval till -1. Can I plug in -2? So 4 plus 4 minus 3. So that's a positive. So in this interval, see here, it's above the x-axis, right? The next interval is, let's see, -1 to 3. I can substitute a 0 here. If I substitute a 0 here, answer is a -3, so it's negative. So between the second interval, do you see? It is negative values for this graph. That's what this is. And then 3 to infinity is the third interval. I'm going to plug in, let's say 4. 16 minus 8 minus 3. So that's a positive value. So you see in the third, from 3 to infinity, it's on a positive interval. So having said this, they're asking where h of x is greater than or equal to 0 in these two intervals. So how do you write it? Minus infinity to -1, starting, ending. Okay. -1 is included. Okay. But infinity has to have a parenthesis. Union. Again, positive, right? Only this part. What are the positive parts? This part and this part. So union 3. 3 is included, right? And infinity is not included. Any questions, guys? This was just a review though. Can I move on? Okay, I think we are good here. Let's see. So now let's come to multiplicity. How do I explain multiplicity? Do you all remember multiplicity of a polynomial? If you all remember, then I'll move on faster, but you have to clearly let me know. Do you remember multiplicity of polynomials? Guys, do you remember or no?
A bit, I guess.
Okay, you guess. Okay, thanks.
Yeah.
So, tell me, ma. Okay. Suppose, see here, we considered this polynomial, right? We were discussing this x squared plus 2x plus 4. Here, when you write it, right, the multiplicity here is 2. See, because this is a linear factor of the polynomial. That linear factor is repeated 2 times, right? So, that 2, right, is the multiplicity, right? Multiplicity, how many times the linear factor of a polynomial is repeating is what is defined by multiplicity. Make sense? Now, okay, let's say, suppose a polynomial, okay, sometimes a polynomial can end up having even multiplicity or it can have odd multiplicity. It can be x plus 2 times x plus 1. This is a polynomial function. This is f of x, this is g of x, or even you can have g dash of x will be equal to x plus 2. See, this is odd multiplicity. Both have odd multiplicity. Power 3, 3 is odd, right? So, in these two cases, the multiplicities of the linear factor is odd. In this one case, the multiplicity of the linear factor is even. Now, what is the difference in the graph? When the linear factor has even multiplicity at minus 2, you know what happens to the graph? The graph takes a U-turn. At minus 2, the graph either takes a U-turn like this or takes a U-turn like this. But what determines it? This one, x plus 2, the whole square can be split as x square plus 2x plus 4. So, when you look at the leading coefficient, it's positive. So, basically the end behavior is like this. The graph has to come from there, then meets here, and then goes up again. It takes a U-turn if it has even multiplicity. Whereas, suppose if it has odd multiplicity, what would happen? There is a minus 2. There's a 0 at a minus 2 and then at a minus 1. You see, here what happens? There is odd multiplicity, right? Usually, if the multiplicity is odd, right, then it will cross. It won't be tangent, meaning here it makes a U-turn, right? If it is odd multiplicity, usually it goes from positive to negative or negative to positive. It crosses the x-axis. Now let's go ahead and see this one. How about this? Okay, how about this? Let's consider this polynomial function x minus 2. Let's erase this off. X minus 2, x minus 5 power 4 and x plus 7. X minus 5 power 4 and x plus 7 equal to f of x. Now we have f of x equal to x minus 2, x minus 5 power 4 and x plus 7. Now I clearly want each of you to show me the graph. Okay. Then also please show the graph and tell me the interval where p of x is less than or equal to 0. If you don't know this, absolutely fine. So what I want from you is show me the graph and tell me the interval where p of x is less than or equal to 0. If you don't know, you can as well send me the details. I'll help you. And then we'll go ahead and find complex zeros. How many complex zeros are there? We'll go ahead and find. Pranav, is this the answer for this one, Pranav?
Yeah. Well, I think I'm not. Yeah.
No, maybe you're right. I'm checking.
No. I mixed up the numbers. It looked weird. So.
Okay. Mhm. Pranav, what is that? 7?
-7.
Oh, okay. And then 2.5?
No, just 2 and 5.
Okay. Nice. So how does the graph look? I just want to see. Navneet, how many?
Should I show you my graph?
Yeah, please. Perfect. Thanks. Navneet, is it only 2? You
I
have
will
showed me only
recheck.
2 intervals, right?
Mm.
What happened to the graph between -7 and 2? Do you see?
Oh, okay. I just
Harshika, did you get it? Avni, did you get it? Akshara, did you get it?
Yeah, I got it. I'm typing in my answer.
Sahana, you remember, ma?
A little bit.
Okay, I really think some of you need input. Shrikar, this is not the way to write, right? Shrikar, okay. Guys, let me go ahead and do this on the board, okay? There's absolutely no problem if you've forgotten. Harshika, do you know how to do this? There's a polynomial x minus 2, x minus 5 power 4, and x plus 7. That's the function. Now I'm asking you to graph it. And in which interval is this polynomial less than or equal to 0 is the question. Abhiram, did you get it? You got it, Abhiram?
Oh, sorry, I didn't hear you. No, I didn't get it yet.
Avni, I'm not able to see you, ma.
I think there's something wrong with my camera because the camera's on, but I don't think it's working.
Oh, I see. Okay. Okay, I'm going to do this on the board. I feel like none of you have answered. Harshika, do you know the answer?
I think I got it, but I don't really know how to write it, and I was having a bit of trouble doing it.
Okay, no problem. Yeah, that's what. Let me go ahead and do, guys. Okay, so there's a polynomial here, right? Clearly, what is the degree of the polynomial? As soon as I see, I'll look for the degree. 4, 1, 5, and then 6. The degree of the polynomial is x power of 6. So it is an x power 6 polynomial. So hard. 6 times did it cross the x-axis? No. Okay. But then there are 6 roots for sure. Okay. So this polynomial has 6 roots. Clearly says one of the roots is 2. One of the roots is 2. The other root is 5. The other root is -7. From here itself, I can find it. Okay, but 1, 2, 3, 4, 5, 6, 7. Let me go ahead and plot the roots. -7, and then x equal to 2, and then x equal to 5. Any questions still here? I just plotted the roots. Now, since I know it is x power of 6, do you all remember the end behavior? X square has an end behavior like this and this, right? See the shape of the graph at the end. X cube will be like this, so my end behavior will be like this, right? That's the only way for me to graph. I need to know the end behavior. X power of 4 will be like this again, meaning it'll be just like x square, x power of 4, x power of 6, all will be similar. But you have to remember that if it is squared, then it will cut the x-axis at 2 places. 4 means it has to cut, see, it won't be like this. So basically it will be like this. X power of 6 will be like this. You see? It has to cut the x-axis at 6 places. Sometimes it doesn't. Sometimes that's where multiplicity comes into picture. Sometimes instead of having 6 separate roots, right, one will be a repeated root. Okay, and then you can cross. One will be a repeated root. Two roots here, repeated root. One root here, 3. And then again, it can go up 4. And then it can be a repeated root 2. You see, these are 2 separate roots. This can be repeated roots. That can also be there. And sometimes the roots need not be real at all. What does it mean for a root not to be real? Suppose this function, this simple quadratic function, if it touches the x-axis, meaning if all of its roots touches the x-axis, then the roots are real. Sometimes it may so happen that your graphs can be like this. They don't even touch the x-axis. Then this function does not have real roots. This function does not have real roots. And do you all remember we learned that non-real roots come in conjugate pairs? What does it mean? Come in conjugate pairs. Do you remember that? Avni, do you remember that?
Sort of, not really.
Okay, not really. Okay. How about Akshada? Do you remember? Ma, please, if anybody remembers, let me know as well. So I would like to understand whether you remember.
I don't
Akshada,
remember it.
you
I
don't
recognize the name, but I don't think, like, maybe
remember
if
it.
I
Oh,
see it, I
okay.
might know.
Okay. Then this is going to take a little bit of time. How about you, Anya? Do you remember?
Uh,
Huh?
yeah.
Yeah, okay. Okay, wait, then let me go ahead and go back and review that a little bit because there's no point in keeping on going, okay? 1 minute, wait. Let's go to a quadratic function. Quadratic function with non-real roots is what you want, right? I really want to graph it and show you. You want one, let's see. With non-real roots you want, right? Okay, let's go ahead and check it out. Okay, how about this? X square plus 4, a very simple function. Guys, I'll come back to this question, okay? There's no point in going through this. Okay, f of x equal to x square plus 4. Let's consider this function, okay? This is a quadratic function, okay? I want to graph it. How to graph it? What is the x coordinate for this one? Do you see, meaning what is the x-intercept here? For finding the x-intercept, you'll make y 0. What happens? X square plus 4. X square will be equal to -4. Is there a, can the square of any number be a -4? So if I take square root, x will be equal to plus or minus 2i. Do you all remember that, guys? This one, do you remember bringing the I because of the square root of -1? You bring up the I and square root of 4 is 2. Square root of 4 can be plus or minus 2. So that is where now the roots of the quadratic function are plus 2i and minus 2i. So this quadratic function, like you see, this quadratic function cannot be written as a product of linear factors because the roots are, meaning the roots are not real here. You see, the roots, when I find, what are the roots? Roots are the x values where your y value is 0. So the roots are not real. That means when you graph this function is not going to touch the x-axis at all. Okay, any complex number can be written in the format a plus bi. A is the real part, b is the imaginary part. A is on this axis, b is on this axis. Make sense? Now, the roots of the quadratic function say it is plus or minus 2i. So this is 0 plus 2i, 0 minus 2i. Which is 0 plus 2i? 0 plus 2i plus 0 plus 2i. Wait. 0 plus 2i and 0 minus 2i. See? Something feels wrong to me. Okay. Okay, the roots of the quadratic functions, this function is 0 plus 2i and 0 minus 2i. So here when you think about it, this is what I said. A plus bi is a complex number means if this becomes a root of the quadratic function in complex numbers, a minus bi is called the conjugate of a plus bi. A plus bi is called the conjugate of a minus bi. A minus bi will also be a root of the quadratic function. That's why we say complex roots, non-real roots. Real roots means nice numbers like this. Nice numbers like 2, 4, 1 by 2, 1 by 8. Any real number will if that serves as a root to the quadratic function, then it'll be like a number on the x-axis. So the graph will cross the x-axis. Whereas if you have complex numbers as roots, then in those cases the roots do not touch the x-axis at all. Here, when you think about it, this complex number plus 2i is a root. So its conjugate minus 2i has to be a root, and that's where we say complex or non-real roots occur in conjugate pairs. Whenever you see a non-real root, it will occur in conjugate pairs. Conjugate pairs means if a minus bi is a root, a plus bi is also a root. Any questions here till now? Any questions here? Any questions, guys? Okay. Now, yet another question here. Suppose if you have the root as 1 plus 2, okay, you will have 1 minus 2. See here, guys, this is not, for that matter, we discuss the complex roots, okay. The other one is real numbers can be rational or irrational. Real roots can be rational or irrational. Remember the 6th grade division of number system we studied. Real numbers can be rational or irrational. But the other system of numbers is the complex numbers, right? Real numbers means, rational numbers means any fraction. Anything that can be expressed as a fraction, or decimals means you should know the repetition pattern of the decimals. Those are rational numbers. So the roots can be 1 by 2, 1 by 4, 0.53, 53, 53. It can be a decimal. Roots can be, these are the real numbers that exist on the x-axis, and you can call them as the real roots. Irrational numbers means the roots can be 1 plus root 2. Square root of 2, square root of 3, pi, square root of 6, square root of 7, square root of 8, square root of 10, square root of 11. All these are irrational. Whenever you see that, they become irrational, but they still remain as real roots, because here you can find out which is 1 plus root 2. What is 1 plus root 2? 1 plus 1.14. 2.14 is your root. So that is a real number still. But then you need to remember, irrational roots occur in conjugate pairs as well. If 1 plus root 2 is a root, 1 minus root 2 is also a root. The same thing happens with complex numbers. 1 plus 2i is a root, 1 minus 2i is a root. So what you need to remember here is real roots are nice to work with. But if you get, even in that, if you get irrational roots, you have to remember that they occur in conjugate pairs. Complex roots also occur in conjugate pairs. Okay. Any questions still here? Any questions still here? Okay. Okay. How do you graph this? I wanted to check on that as well. Okay. Here the thing is, since you have for the same function, let's find out x square plus 4, right? The way you graph this is here. You see, the graph will be like this. Okay, this is 1, this is 2, meaning you plot the real numbers on this axis, the complex numbers on the imaginary y-axis, imaginary part on the y-axis. So here the functions that have non-real or complex roots will never have x-intercepts. Makes sense? It will be either up here or like this or like this. They will never touch the x-axis. Okay. Now let's go ahead. Let's go ahead with more problems on that. How about this, guys? Okay, you're going to tell me, I want you to give me a minute, guys. This is important, guys. Without this, we cannot proceed with this, right? So let's go ahead and see this one. X square plus 2x plus 5. X square plus 2x plus 5. X square plus 2x plus 5. This is a quadratic function. Okay. Please tell if it has real roots. If it has real roots, you can as well tell rational or irrational. Just find out what are the roots. You remember the discriminant, guys. Discriminant is equal to 0. Discriminant is less than 0. Discriminant is greater than 0 determines the type of roots. Discriminant is equal to 0 means unique, non-repeated roots. Non-repeated real roots. Right? Discriminant is less than 0 means complex roots. Complex or non-real roots. What is discriminant? Do you all remember? Anya, do you remember what is discriminant?
Yeah,
What is it?
it's negative 4ac.
B square, good ma'am. B square minus 4ac is the discriminant. Makes sense in a quadratic function written in the format ax square plus bx plus c. The discriminant is b square minus 4ac. Now, when the discriminant is less than 0, it has complex or non-real roots. Discriminant equal to 0, unique, non-repeated real roots. When discriminant is greater than 0, it is another Pandora box. Discriminant is greater than 0, there are two other cases. The discriminant value can be a perfect square or it need not be a perfect square. Okay, if it is a perfect square, then you end up with two distinct real rational roots. Okay, if it's a perfect square, then you end up with two repeated, I think, ma. Two repeated real rational roots. If it's not a perfect square, you end up with two distinct real irrational roots. This one is from algebra 1. Okay, now you can use your quadratic formula, does not matter, but I would like to know what are the roots of this function, whether they are real or not, real or complex, whatever it is. I just want to know whether you're able to find the roots of this quadratic function. Can you check? Can you try, guys? Did you all get it? If you didn't get it, you have to let me know that you didn't get it, and where are you stuck, you have to let me know. That's fine. I really want to know what are the roots, Avni. Yeah, the roots are what I want to know. Are you able to do Akshada, Avni? Are you able to do, or do you need help?
I'm in the middle of doing it, but I'm able to do it.
Okay. Will it be one root or two roots, ma, Akshada?
I put plus or minus to show two roots.
Ah, okay.
Yeah.
I did not get it. Okay. Wow. But is the sign correct? Mahir, are you following Mahir?
Yes, Auntie.
Okay, so here x will be equal to minus b. What is the quadratic formula? Minus b plus or minus b square minus 4ac by 2a, correct? So minus b plus or minus b square is 4 minus 4 times a is 1 times 5 divide by 2 times 1. Shrikar, are you with me, Shrikar?
Yeah.
Divide by 2. Minus 2 plus or minus square root of minus 16. That is why you get complex roots. So here minus 2 plus or minus, what is square root of 14? See, square root of minus 16 can be written as square root of minus 1 times square root of 16. Square root of 16 is a 4. Square root of minus 1 is an I value. Okay, but I you should not be writing it at the start, but you should be writing it at the end. So this becomes plus or minus 4i by 2. But divide each thing by 2. You get minus 2 by 2 is minus 1 and then plus or minus 2i. Akshada, did you see that? It would be minus 1.
Yeah, I corrected it.
Okay. Harshika, did you get it?
Yeah, I got it.
Okay, so this might be a revision, but you need that to trigger your brain points which are storing it but not retrieving it. Sahana, did you get it?
Yeah.
How about you, Ma? Anya?
Yeah.
So this is how you get the complex roots. But as you can see here, I told you, right? Complex roots occur in conjugate pairs. So what does it mean here? You see, minus 1 plus 2i is one of the roots. The second root is the conjugate of it, minus 1 minus 2i. So if it is a complex root, it has to occur in conjugate pairs. Okay. Now let's see this one, a little bit harder one. Let's see. 1 second. You know what? I don't know if I can get it right off. Let's see. Let's see. I don't have ready-made questions. Wait, guys. Let me see what I can do. Okay. Okay. How about this? Okay. Let me ask you this. Do you know how to write a quadratic equation if the polynomial, which is a quadratic function, has the roots is this? The roots are given by minus 4 plus I and minus 4 minus I. Do we know how to frame the quadratic equation for this function? Do we know, or do you need help? Sahana, you tell me, do you need help or you know? Sahana, just let me know, ma. Anything is okay for me. You need help or you know? Hmm? Hey, Sahana, I didn't hear you and you muted yourself. That's so hard.
Sorry. I said I think I need help.
Okay, how about you, Shrikar? Do you know how to write the quadratic equation? Okay, let's see. Okay. Just message me, guys. That also works. You don't have to be open. But it's okay to be open to you. Don't know, you don't know. There is nothing wrong. And I'm going to go over it. Okay, I think some of you definitely need. Abhiram, do you want it or you know?
I know.
Oh, you know?
Oh, this one, no. Could you please explain?
Yeah, I can. For most of you are saying, Avni, do you remember, ma?
Yeah.
You remember?
Yeah.
Okay. So let's say the roots of a quadratic equation are 2 and minus 2. How do you write the linear factors? That means that 2 and minus 2 is going to be a 0, right? So x will be equal to 2 or x will be equal to minus 2. That's what you know about them. So how do you go about it? Bring the 2 to this side, you get x minus 2 will be equal to 0. Bring the 2 to this side, x plus 2 will be equal to 0, right? It's a quadratic equation, right? So combine both. X minus 2 can be a 0 or x plus 2 can be a 0. This is your quadratic equation, right, guys? But here you've expressed them as linear factors. What will you do if you want the equation? You'll write x squared minus 2x plus 2x minus 4 will be equal to 0, right? X squared minus 2x plus 2x. So what would happen here? X square minus 4 will be equal to 0 or that will be your f of x. This is the equation of the quadratic function. That's what you do, right? Here, the roots are very nice, real rational numbers. But here, this makes it so complicated. What makes it complicated? The roots are imaginary. The roots are complex numbers. How do you write the linear factor here? X minus 4 plus I, right? The next second linear factor. Shrikar, are you with me? X minus 4 minus I. I'm just writing it the linear factors, that's all. Now let me rewrite this. Let me put the distribute the negative sign. X plus 4 minus I. This one becomes x plus 4 plus I. That is even more complicated. How to multiply these? That's what makes it complicated. X squared. What happens then? Then you have, so basically what I would do, I would not keep multiplying this like this. Okay, let me tell you what I do. Let's say, you see, I will regroup this. Okay, instead of multiplying one by one, you know what I would do? I will take this out as A, B. A minus B, A plus B. What is the formula for A minus B, A plus B? A square minus B square. X plus 4 the whole square minus I square. Did you get it, guys? Am I with you? Okay. Now that becomes x plus 4 the whole square. You know how to do that, right? What is that? X square plus 16 plus 8x minus I square is a minus 1, right? X square plus 8x plus 17. That is the equation of this quadratic function. Any questions? Okay. So let's go ahead and try more. How about this? I really want you to be able to do some. Let's see, guys. How about this? Sixth one. Why don't we solve this one? Okay. Can you solve the complex roots of this quadratic function? What are the complex roots of this quadratic function? I just want to know who logged off. Go ahead, guys. Did you get it? Oh, guys, you're all getting a hang of it now. So, see, revising this really helps you with SAT. Okay, it's not a part of pre-calc. Okay, I would have said, okay, go revise. No, right? At the end of it, you should be able to do your standardized test well as well. A little bit of review really helps. You don't have to re-prepare for SAT. So, keeping in touch makes you not to forget. You get it? Yes, ma, Sahana. Shrikar, that's right. Pranav is gone. Akshara, okay, I'll do it on the board. Seema, x will be equal to minus b. Then plus or minus b square is 16 minus 4 times a times c divide by 2 times 4. Right, Akshara? Are you getting this, Akshara? Now, this
Yeah.
would be plus 4 plus or minus 16 minus, what is this? 16 times 5, right? 16 times 5 divided by 8. Take that 16 as common. You get 1 minus 5, which is a minus 4. So this is inside it. Divide by 8. What is 16? See, you take the square root of 16 times minus 4, right? Square root of minus 1 becomes that I here. Other than that, square root of 16 is a 4. Square root of 4 is a 2. So that becomes 8i. Got it? Now, this is 4 plus or minus 8i by 8. Now, divide, that becomes half plus or minus. Again, 8i by 8 becomes 1i. So, half plus or minus I are the roots of this quadratic equation. Any questions? It's important to be able to find out the complex roots of a quadratic equation thoroughly. Okay, let's continue that. Give me a minute. How about this? Okay. Okay, so let's see this one. Let me ask you this question. One root of the quadratic equation is this. What is the other root? One root of the quadratic equation is that. What is the other? Do you guys remember? Shout out, guys. If you know, just shout out, please. What is the other root? Guys, you can shout out. It's a complex root, right?
Is it 5 plus or minus, plus 3i?
Correct. 5 plus 3i is the other root. You know, if you want to write that quadratic function, how do you write it? X minus 5 minus 3i. That is one root, right? And then the next one would be x minus 5 plus 3i. Here, you know what? How to find out that function? First, distribute the minus. X minus 5 plus 3i. So that you need to multiply with x minus 5 minus 3i. But that's so difficult. I don't want to multiply one by one and make my life harder. I'll take this as A, B. A, B. A plus B, A minus B. Formula is A square minus B square, right? What is A here? X minus 5 the whole square minus 3i the whole square. What is x minus 5 the whole square? x square plus 25 minus 10x. 3i the whole square is what? That becomes 9i squared. But there is a minus in here. Don't forget that. Minus I'm copying. But what is minus 9? What is 9i squared? I square is a minus 1. So that becomes minus 9. Now the minus and minus become plus. When you add it in here, it becomes 34. So the equation of the quadratic function becomes minus 10x plus 34. Any questions? Any questions, guys? Okay, I'll do one thing. I could not finish or get to fully the pre-calc version of complex roots of polynomial functions. So this week I'll go ahead and give you a review homework on Algebra 2's complex roots polynomials. Does that do good, guys, for you to revise? Okay, any questions for me? Any questions for me? Can we stop here? Have a nice 1 week break, but definitely please revise this and come. I'll provide the homework. If you don't have any questions, we'll see next week.
Auntie, I have a question.
Yes, please go ahead.
Where do we access the class recordings? Like, do you still take those?
Yes, I still take those. The recordings are there in the classroom. You know what, Chetan? There is a Google Classroom. Your mom should have gotten the welcome email. Okay. Will she be able to help you to get to the Google Classroom? Because the welcome email has the link to the Google Classroom. Would it
Okay,
help
cool.
you?
Yeah, and we don't have class this coming week, right?
Why we have?
Oh, we do. Okay, thank you.
Yeah,
I
we
just need
do,
to make
but
sure.
the time, if there is a change, I'll let you know.
Yeah. I think I got that confused with if we had class or not, but there's a time change coming up.
Yeah, time change is definitely coming up, but I don't know. Harshika is coming and saying I can't do. I don't know what to do, but
Okay, yeah,
that's what.
that's fine. Thank you. I just needed to know the recordings. Thanks.
Sure, everything is in the Google Classroom. You have to watch and stream. Till last week, it's posted in Google Classroom, Chetan. Does it help you?
Yeah, I missed 2 classes in between, so I'm just gonna go back and look at those.
Absolutely. I made sure I posted all the recordings in Classroom.
Okay, cool.
Okay, Sahana, any questions for me? Guys, if you're done, you can leave and we'll see you next week. But please do the homework, review, and come back. Otherwise, it's dragging.
Thank you.
Yeah, ma.
Thank you,
Bye.
Miss Priya.
Bye,
Yeah.
guys. Bye, guys. Okay. Hi, guys. How are you all? Was the last week homework doable, guys?
Yeah.
Okay. It was in transformation, right? It was in transformation, correct, guys?
Yeah.
Did you need help or were you all okay? JSI and Johan, tell me.
No, I was good with it.
It was good. Ma'am, I can't on my camera because the laptop it's old. I can't use my mom's because she has classes on it.
Okay. Pick up, Prisha, Shreya, Vinisha. Oh, wow. Okay, did you all get to check Johan? How was the homework, Johan?
It was good. I finished it and submitted, so.
Hey, who is this in the classroom?
Ma'am, that's me.
Oh, that's you. Are you also there in the pre-cal classroom,
Yeah,
Jason?
ma'am. I don't know why, but you sent me both of those classes and I joined them both because I thought my parents did both.
Oh my gosh. No. Okay. Okay, I'm not checking this time, but let me see. First of all, I need to clean up that because I was asking, who is the Zoom? Who is the Zoom? I was asking. Okay. Okay. Johan, did you have any questions in the homework?
No.
No. How about Sanshri? Did you have any questions? Srishti, did you have
No,
questions in
ma'am.
the homework?
I turned it in.
You turned it in. Okay, yeah, I saw. Okay, just one second. I'm going to get the book, but you know what? I really want to finish something else. Generic topics I want to finish before I get to the book. Okay. If we get into the book, we'll get overly into the book. So let's see. Mm, yeah, that's what I want to do. Okay. You know, if I give you functions, I would really want you to be able to do 1 second, versus and composition. Okay. This is what I want you to do. Let's see. Okay, one is info composition, even odd function will finish. Yep. Let's see. One second, guys. I just want to make sure I'm doing it right. Okay. Okay. Now, if a function is given, right, in the parent parent functions packet, right? We were discussing whether this function is even, odd, right? And we always said if it's symmetric about the origin, then it is odd. If it's symmetric about the x-axis, it's even. And if it is not both of these, then it is neither, correct? So now let's go ahead and find out. Okay, graphically, we were always telling, hey, you have to do this. You have to find the symmetry about the origin and stuff, right? So given any function, be it a cubic function or a quadratic function or an absolute value function or a linear function, you should be able to find out whether it is even or odd. Okay, graphically, I know you're at a point to find it out. Okay, now let's say if I have a function like this, would you be able to plot it correctly? How will this function be? Anybody who can draw it on the board and show me what will be the graph for this? You did transformation homework, right? What will be the function graph? Or am I expecting too much? I don't know. You have to tell me, guys. Yes, I know. I don't know. Anything from you helps. Last year, you tell me, Ma, would you be able to graph this?
Yeah,
Oh, you'll be able to?
I can try.
Yeah, please. So for that matter, right, square root function is like this. What is this function? This is also a square root function, but a transformed one. Where will the transform graph be?
It's 2 units to the left.
Yeah, that's it. It's 2 units to the left. So the graph will be like this, that's all. Like the same. Okay. Any questions? That's nice. So now let's go ahead and see. We are going to find out even and odd functions, both algebraically and graphically as a part of today's unit. Okay. Okay. Before I go ahead, right? Okay. Let me put up what I'm going to tell you. We'll do one by one. Main part of today is finding it algebraically. I know that you will be able to do it graphically. Okay. Now, you will classify function as even, odd, or neither, right? So now let's see. When I ask you to do it graphically, you're at a point where you can find out. But when I ask you to do it algebraically, you're not at a point to find that. Okay. So here, visually, you know, y-axis is the axis of symmetry means then it is an even function. Odd function means it should be symmetric about the origin. However, algebraically, what I'm going to find out, this is what you need to know. Even functions will have f of x is equal to f of minus x. Odd functions, right? See what happens. F of minus x will be equal to negative of f of x. Here both will be the same. What does it mean by this? So be it any function given, f of x, let's say the function is x squared plus 1. The function is like this, right? I will, wherever I see x in it, right, I will try to substitute f of minus x. When I substitute that minus x, right, what change happens? I'll try. Instead of x, I'll put minus x and see. See what happens? F of minus x will be equal to x squared plus 1. Oh my goodness, see here? It just remains as f of x. Do you see? So what can I conclude from here? F of minus x is equal to f of x. It doesn't change at all. If I negate the input, I get the same output. You see, even if I negate my input, I get the same output. Then the function is considered to be even. Make sense, guys? We'll do one more. I'll do one more. That's what I meant. Okay, let's see this one. One second. I don't want this. I don't like this. Wait. One second. Okay. How about this? Can you do this for me? Okay. What is x power of 0, guys? What is x power of 0? I'm just asking, what is x power of 0?
Well, equal to 1.
Yeah, equal to 1. You should remember that. Now, let's see. X cube minus x. I'm going to consider the function f of x equal to x cube minus x. This is a function. We don't know what function is this. But we want to find out whether it is odd or even algebraically. What do you do if I want to find out algebraically? Instead of x, I'll start substituting. Wherever I see x, I'll substitute with a minus x. Right? But then x is cubed, so I'll cube minus x. And then minus, I'll copy that. Instead of x, I'll put a minus x. What happens here? F of minus x will be minus x if I cube, right? What happens? Minus x times minus x times minus x will be, answer will be a negative, but then x cube. Negative x cube plus x. Wow. What happens here? Any thoughts? How did this change? F of minus x became, see, the x cube became minus x cube. The minus x became plus x. So can I call it as minus of f of x? The negation of f of x means what I got was f of x multiplied by a minus 1. Did you see it? If this is the case, the function is considered to be odd. See, the f of minus x equal to minus of f of x. Make sense, guys? Then the function is considered to be odd. Srishti, did you follow?
Yeah, I was writing it down.
Yeah. No. If you're with me, fine. Vibha, did you follow, ma?
Yeah.
Priya, did you already study this there? No?
No, but I understand what you're saying.
No. No. Did you already study in the other course?
No.
No? Okay. No, but this is very important. Okay, this is the base. Odd even functions and then function composition. Did you study function composition? Okay. Function composition and odd even, both are important. Okay. So when f of x is equal to the negative of f of x, then it is an odd function. When f of x is equal to f of minus x, then it is an even function. Now, can I go ahead and try giving you something for you to find out? Let's see. Okay. Graphically, you know, okay. How about this? What function is this? You can say odd, even, or neither. What function is that, guys? You are going to try.
Neither.
Good job. That's neither, because it's neither, because it's not symmetric about the y-axis. It's not symmetric about the origin. So it's neither. I'm going to give you three functions. You're going to send the answer to me. Algebraically, find out if it is odd, even, or neither. Please send it as 1, 2, 3. I'm waiting for your answers. You can say 1, 2, 3 until odd, 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 like that. 1, 2.
Miss Priya,
Yeah, ma.
I have a question.
Yeah.
Would it be possible to just define or understand the functions if they're even or odd just by looking at their powers?
Yes, you can.
You can do that? Okay.
You can. Tell me, what are your thoughts? How to?
I feel like if you have the same if you have any external factor such as probably the coefficient or constant, it wouldn't really change how the graph forms because we still have the same parent function.
Correct, but based on the all the exponents of the variable are even means it's going to be an even function, right?
Mm-hmm.
So all the exponents of a variable are odd, is going to be an odd function, right? If it's a mixture of odd and even, it's neither.
Okay.
But how about x power of 0?
X power of zero.
X power of 0 is?
It would be neither because everything's just one or
No, if x power of 0 is even. X power
yeah.
of 0 should be taken as even. That's the catch there.
Mhm.
Make sense?
Yes, ma'am.
X cube. So now, okay, yeah. So let's see. X cube minus x. Let's consider x cube minus x. Does it obey? Let's see. Let's consider x cube minus x. This is odd. This is odd. So is this an odd function? Yes, it is an odd function. Make sense? How about x square plus 1? X square plus 1. This is even. Here, 1 has x power of 0, right? That is considered even. So this is an even function. Good question, JSI.
Mm-hmm.
Okay. Now, how about these? How about these, whatever I've given? You don't need to work that out as well, but it's important that you know how to work it out. F of x, if f of minus x is equal to f of x, then it is considered even. If f of minus x is the negated value of f of x, then it is considered as odd. This thing you need to know, and you need to know how to apply minus x instead of x. That's why I am enforcing you to do that for these problems rather than using the shortcut to find. Make sense?
Yes, ma'am.
But
Miss
it's good
Priya,
to
I'm
know the
not
shortcut.
like Miss Priya, I'm not understanding it that much. Can you like
Oh,
explain it?
no problem. Yeah, I can go over it. Okay. Let's say f of x. I said what I'm saying is when there is a function, in this function, see, what is my input? Input is x, right? My output is what? My output is f of x, that is minus x cube. So what does it do? This function basically cubes my input and then negates it, correct? What I'm saying, instead of giving x as your input, change it to the negation of x as your input. So wherever you see the x in the equation, I'm going to plug in a minus x. Make sense? Here, just copy the minus. But you see an x there, right? I'm going to plug in a minus x and then cube that. When you cube minus x, what will happen? What is the answer for cubing? If you cube minus x times minus x times minus x is what is the answer?
Negative x cube.
Negative x cube. But this negative is there. Don't forget that. That one. And then negative x cube, right? Now the minus and minus become plus. That becomes plus x cube. Make sense? When you think
Yeah.
about it, f of x was the negated value of this, right? So f of minus x will be plus x cube, means the negated value of f of x. Make sense?
So how to know if it's even or odd?
Yeah, that's what I'm saying. So if this condition is satisfied, it is odd. Whereas sometimes you'll end up with that f of minus x is not the negated value, but it's just f of x. Then it is even. Make sense?
Yeah.
Okay, why don't we try with this one, third one. F of x equal to x square plus 4. So to find out whether it's an even function or odd function, my first process is to substitute minus x instead of x. Right? I substituted. Now let's simplify this. F of minus x will be, when you square minus x, what happens? Minus x times minus x is what? Plus x square plus 4. Correct? Now is when I fed minus x as my input to the same function, I am getting the same f of x as my output. So can I write f of minus x is equal to f of x?
Yes.
Now, what is this function? Can I conclude that it's even?
Yeah.
Who did not understand this? Avyuk, did you get it?
Yeah, I got it.
Okay, how about this? You know, my first process is to substitute minus x instead of x. See, minus x the whole cube. When I do that, minus x times minus x times minus x returns minus x cube. So I wrote it out as minus, I put it outside, so 5x cube. So what did I get? 5x cube is my input, but there is a negation of that. So I can write, instead of this 5x cube, I'm just plugging in this in. So it's a negated value of f of x. If this condition is satisfied, is the function even or odd, Sanjay?
It'll be odd.
Yep, odd. Now, did you get it?
Yes, ma'am.
Okay, I'm going to give you one or two more for practice. I don't have anything here. One second, guys. That's so hard. Okay, let's find out. Okay, okay, Shreya, I know why they might not have covered this, I feel. Let's see. How about this? Okay, try answering this. This should be an easy one. This should be an easy one. Try answering that. Which of the following describes an even function algebraically? Which one is it?
Okay. Okay.
A, good job. A, yes. Is there anything else? Is there anything else?
D.
Yeah. Yep. 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 Okay, but you know what? In this case, right? What is the question is what the question is asking? The following describes an even function algebraically. Oh, this is C. Describes an even function algebraically. They're asking for the rule. This is the answer. This is an example of an even function. Make sense? Okay. Now let's keep going. I really want you to work more problems on even and odd functions. Give me a moment. I need to check from my drive. Wait, guys. Okay, how about this? Can you find out x power of 4 plus 3x squared plus 7? X power of 4 plus 3x squared plus 7. Is this function odd or even? Please send in chat. Question number 1. X squared plus 9. This is interesting. Try this one. You can tell me these two. Find out algebraically. I know you all can find it graphically very easily. Don't use that. You get it? I had two questions. Let me know if you're not able to do. I would be more than happy to help.
I said my answer.
Yeah. 1 second.
Also send my answers.
Um. Oh yeah. Yep. That's easy. Johan, why do you say neither for the second one?
Because even though it would be considered even, it doesn't really reflect over the x-axis. Y-axis.
Square root. What function did I give you? I just gave it whatever I felt like. Hmm. You have a point there. Hold on. Okay. So everybody has it as okay. Um, I just want to see the graph of that. Hold on.
Wait, never mind, I graphed it again. Okay.
Did you graph it?
Yeah, it's not the one I was thinking, so yeah.
Yeah, it is not the. Okay, you thought square root went to the left by 9, correct?
Yeah, I
Yeah, even
kind of
I
forgot
thought,
about that.
yeah, even I thought square root went to the left by 9. Now only I realize it's x square plus 9, correct? So basically, you know how to decide, Johan. Okay, this was a good question from him. He says g of x graph. Sincerely, I also thought it was the square root function. That's why I was thinking, what's going on here? Square root function. If it is the square root function to the left by 9, then it should have been like this, right, Johan?
Yeah.
But there was an x square. So how to verify this, One another point to verify. If a function is symmetric about the y-axis, right, I would find g of 2. Let me find out what is g of 2. It will be square root of 4 plus 9, 13. What is g of minus 2? Again, it's square root of 13. You see it's symmetric about the y-axis clearly. Then again, I would try to do g of 1. This is square root of 10. G of minus 1. It's again a square root of 10. You see, it's always negating. It's always the same for equidistant points from 0. 0 to 1, 0 to minus 1. 0 to 2, 0 to minus 2. So it is symmetric about the y-axis. Or I will go ahead and substitute g of minus x would be minus x the whole square plus 9. It just remains the same. It doesn't change at all. So I can say g of minus x equal to g of x. So the function is even. Make sense? JSI, did you get that?
Now I think both my answers are wrong.
No, okay, you got it?
Yeah.
Okay, nice. How about this? Okay, how about this? Okay, let's see whether we are able to find this one. I don't know. It's a challenge problem though. Let's see. Try, guys.
Should we find if it's even or odd, Miss Priya?
No, no, the question is on the board, right? Find the value of k. Oh, you were not given the full problem. Sorry. Okay, that makes it an odd function. That makes f of x an odd function. Sorry, Sanshri.
Only for k, which means it odd. But would that not be?
Let me know if you didn't get it. I'll help you.
Because if you're multiplying it, right? So, Miss Priya,
Yeah.
would that have to be a no integer, or can we make that like a variable such as x2?
I don't get your question. Can you elaborate, Jason?
So, like for k, could we make it so that k is equivalent to x?
No.
We
Okay.
can.
Okay. Let's see. What is the condition for a function to be odd? F of x should be the negated value of, I'm sorry. When I substitute minus x instead of x, that should be the negated value of my original function, correct?
Mm-hmm.
Okay. Now, how do I find this f of minus x? Can I bring something, meaning, can I feed instead of x, can I substitute minus x in all of this?
Yeah.
Yep, plus k times minus x the whole square. These are all a level up though, but then it's very useful when it comes to your standardized exam. Minus 4 times minus. Any questions on that?
No.
Okay. This will be equal to the negated, see, this is f of x. When I multiply by minus 1 on that, what would happen? Minus x cube minus k x square plus. Does it make sense, guys? Till here, are you with me, Srishti?
Yeah.
Now, what do I do here?
Miss
I have to
Priya,
expand. Yeah, ma?
wait, why wouldn't it be positive kx squared? Because when you square to negative x, it becomes positive.
Here you're asking?
Yeah.
Are you asking here, Johan?
Yeah.
What I'm doing is I'm just negating f of x. This is my f of x. I'm multiplying by minus 1 on both sides.
Okay. Okay.
You get it? See, minus of f of x is nothing but minus 1 times f of x. Does that make sense? Yeah. This is not the same as finding f of minus x. Does that make sense?
Yeah.
In finding f of minus x, you are wherever you see x, you are going to plug in the minus x. You got it?
Okay. Yeah, I get it now.
Yeah, so that's the difference. Here. Okay, this is what you did on the left hand side. This is what you did on the right hand side. Now let me elaborate this. Minus x cube, then this is anyway square plus kx square plus 4x. So that will be equal to minus x cube minus kx square. Oh my gosh, wait guys, something is wrong. Plus 4x. I didn't get what I wanted. 1 second. What did I do? I found out f of minus x. Okay. It's an odd function. So odd function. Yeah. Yep. So what happened? Okay. I think we are on the right route. Let's go ahead and see. Because whatever we have done is correct. So plus 4x, right? Now what happened here? This and this gets cancelled. Plus 4x get cancelled. I'm left with kx square will be equal to minus kx squared. What does it mean? Add kx square to both sides. Let me see. So 2kx square will be equal to 0. What does it mean? K will be equal to 0. That's all. Make sense? It's an easy one, but a tricky one. Sanjay, are we clear? Or are you still stuck?
I'm a little confused.
Okay, where are you confused? Tell me, I'll help you.
Like, I'm just not sure what you mean by like f uh
This one,
times negative x.
I know where, I think I know where are you confused. This and this you're not able to understand, right?
Uh, yeah, a little bit.
Correct, right? Yeah. See, absolutely okay, right? Because this is the first time you're getting introduced, and it's okay to say that. Okay. So, see, okay. Let me go back. I really want you to understand, everybody to understand this. Okay. So, what I'm saying is there is a function given. Okay. When I say f of minus x means the input x that I'm feeding, I have to negate it. If I negate my input, wherever I see x, right, this x will become minus x the whole cube. Then this x, right, will become minus x the whole square. Then this x, right, will become minus x. You got it?
It's fine.
Now, this is f of minus x, meaning you're negating the input to the function. Okay. But when I put minus f of x, this is different. I'm not negating the input. I'm negating the output here. Do you see it? I am multiplying f of x by minus 1. So I have to multiply the entire thing by minus 1. So this becomes minus x cubed plus minus kx square plus 4x. You are just negating every term. You got it?
Yeah.
Now, if both are, let's say, this f of minus x, you are able to simplify it to f of x, then it's an even function. By giving the negated input, if you are able to prove that that is equal to the original function multiplied by minus 1, then it is an odd function. Am I clear?
Yes, ma'am.
Avyukt, are we clear?
Yeah.
Okay. Let's see this one. I'm still not convinced that you guys understood, but let me know, guys. Whatever, if you did not understand, then we need to go over it. Let's see. How about this? Okay, I want you to do this one. You get it, guys? Let me know if you're stuck. Just be blunt. I did not understand, and I'm absolutely okay not to understand. They can give you any type of function, meaning, see, the base during the summer, I really want that to happen. Be it any function, you should be able to tackle the given question with ease. Does not matter whether it is cubic, quadratic, any function. But we'll do one by one function as we move on into the year. Mhm. I need to have an answer ready, right? Yeah. That's not a hard one, guys. Go ahead. I definitely give you an easy one.
I'm not sure, Miss Priya. Miss Priya,
Yeah.
I need to know.
No problem. I'll help you. Sanjay heard you. Shreya, both are equal to that value? Good. That's fine. Lasya, Avyuk, I'm waiting to see your answers. Johan, looks like Srishti is all set, isn't it?
Yeah, this one wasn't that tricky, I don't think.
Yeah, that's what I thought. Yeah.
Yeah.
Okay. I know something, there is a mind block for some of you. That's what I feel. Okay. So here, f of x, okay, I'm going to do it on the board, okay? Find the values of a and b that makes this an odd function. When will it be odd function? When f of x is equal to the negative, when you give a negative input, that will be equal to the negated value of the original function. Then only it's odd, right? So let me find this. How to find this? I have to substitute all the x's with the negative of x. Just blindly I'm substituting. I'm not doing anything right now. Okay? Will be equal to. Now, how to find this? You know, I'm going to write the same thing, but all with the negatives of whatever is existing. Minus ax power of 4 minus 3x cube minus bx square plus 5x. Any questions, guys, still here? Did you get it? Now I can
Yeah.
equate. Okay, before equating, first I need to find out what is this. Minus x power 4 is what? Minus x times minus x times minus x times minus x will be positive x power of 4. So I'll write it out as ax power of 4. This one will be negative, minus 3x cube. This one will be positive bx cube, bx squared. And this is plus 5x. So that I'll equate it to minus ax power of 4 minus 3x cube minus bx squared plus 5x. Now it's very easy for me to find out. I just directly equate this to this. Directly equate this to this. It's already equal. Directly equal to this. So ax power of 4 will be equal to minus ax power of 4. Then bx square will be equal to minus bx square. So what happens? Add ax power of 4 to both sides. 2ax power of 4 will be 0. A will be equal to 0. Similarly, 2bx square will be equal to 0. B will be also equal to 0. Did you guys get it?
Yes.
Okay. Now, coming back and brushing to classify. I want to classify a couple of functions, whether they are even or odd. Let me go back to where I was. Okay. Tell me whether these two functions use the same numbers I've given. This I'm not going to work it out. Okay. I'll be waiting for your answers. Classify whether they are even or odd. Okay. One another thing I am going to give you is f of x. I'm going to give this now. F of x will be equal to x times absolute value of x. Try, guys. Let's see. If you want, I'll write it here. If you want, you are going to negate the input. What do you get? If you get the negation of your output, then it is odd. If you just get f of x, then it is even. Same thing. That's all. I don't know whether this was easy or hard. Let's see. If you need help, still does not matter. Please let me know. Okay, please don't sit there quietly and go. You're just wasting your time. Johan, you got it. Jessa, can you check the fourth one? Srishti, that one is right. Shriya, correct me.
Oh, I'm confused on how the fourth one's wrong.
Come again?
How is the fourth one like wrong? I'm kind of confused.
Fourth one, huh?
Mhm.
Okay. Can you do it on the board? I can help you. So that way we fix where you have trouble with. Can you do it on the board, JSI? If you
Uh,
don't want to, no pressure. But if you can do it on the board directly, right, with the mouse quickly, right, I can help you fix wherever you're making.
I can't write with the mouse.
What is it?
I can't write with the mouse.
You can try, okay? It's not okay. Okay, let's go ahead. You shout out. Where did you go wrong? What did you write? F of I have this function. What did you do?
Ma'am, we're talking about the fourth one, right?
We are talking about the fourth one, huh?
Yeah, the absolute value function.
Sorry. I was talking about the third one. Okay. Fourth one is this one, right?
Mm-hmm.
So I'm going to find out. Oh my gosh. Okay. We are going to talk about, we want to find what is this in both the cases. I want to negate the input and find out. Negate the input. Okay. I'll start substituting minus x instead of, what is the absolute value of negative x?
It
It's
will be
x.
x.
Yeah. But this one still retains that. So what happens will be minus x. Correct?
Mm-hmm.
What happened to it now? Oh my gosh. One second. I made a mistake with one pre-calc student. Wait, this.
Venkatesh or Venkat.
1 second, guys. 1 second, guys. Sorry. Okay, guys. So what happened here? What did you conclude? Johan, how did you go from here?
I just thought that because the negative wasn't really with the x in parentheses, it was outside, and that meant it was negating the y value instead.
Yeah. So it is
Odd.
correct. So here you see the f of x is x times absolute value of x. Um, okay. Okay. Uh, um, who asked this question actually? JSI, right? Okay. So when you think about it, right? F of x, if I feed in positive x, right? What happens here? X times x, which is x squared. You see, when I feed in negative input, right? What happens? It becomes minus x squared, which is the negation of f of x. Does it make sense, JSI?
Yes, ma'am.
You feed in positive x, you feed in negative x. See what you get. If you're able to get the same thing, then it is even. If you're not getting the same thing, but the negation of the previous one, then it is odd. Does it sound good? Avyuk, did you get it, Avyuk?
Yeah.
Oh yeah, you all got it. Nice.
Priya, did I get it right?
Yeah, Avyuk got it right. Who else had the
Sanj.
doubt? Shreya, let's see. Lasya, is the order correct? The second one is what, Malasya? Correct, Sanshri. Lasya, this one, what did you get? Lasya,
Yeah, Miss Priya.
what did you get for the second one? Shout out, it's okay. I'll help you if it is wrong. If it is right, I'm going to say it's right. Tell me.
But I was really stuck and I don't know, I guess I just need.
Okay, so I'm going to plug in negative x there. Okay, when I feed in positive x, I'm getting this. I'm going to feed in negative x. What happens? Minus x power 5. What is minus x power 5? You tell me.
Negative x to the power of 5 stuff.
Yeah, negative x power of 5. The parenthesis goes off, right?
Yeah.
Yeah, here, what is minus 4 times? I don't know. So let me put minus 4 and then minus x, the whole cube is? Again, there is a minus and that turns to a plus, right?
The x, 4x
Yeah,
cubed.
and then plus 2x. Again, I have to substitute minus x in here. So that becomes minus 2x, correct?
Yeah.
So what happens here? When you look at it, right? F of minus x is the same as f of x, but all with negative values, you see?
Oh, I see.
So I can conclude f of minus x is equal to negative of f of x. So it is odd.
Odd.
Make sense?
Yeah, I understand.
Yeah, no worries. Okay. Okay. So this is, yes, Abhyut, tell me. Sorry. Tell me.
Algebraically, is there a way of how to tell it's both ways?
Abhyut, repeat your question, please.
Is there a possible way of telling it's both even and odd?
I'm not getting your question, Abhyut. Maybe I did not understand. Repeat again.
Can a function be both even and odd?
No.
Oh, okay, okay.
It can either be even or odd or neither.
Okay.
Because can a function ever be symmetric around the origin and the x or y axis?
Okay, I see. No, I can't.
Yeah. So graphically, you already know how to. Let's see. Now, you know what I want you to do? Yeah, I was looking at this one. Let's see. Even odd. Okay, I think we are good for your thing. Okay. Okay, you want one hard one? Algebraically, I'm not going to give you here. Okay, you go do it at home. How about this? This is the last one. Fifth one. Let's see. Is this odd, even, or neither? Go ahead, guys. You had the answer, Shreya? Yeah, that's true. Yeah, that's true. I didn't calculate it mentally. I thought I had to do it and see. Then only I realized. Avyut, I'm waiting for your answer, Avyut. JSI, correct. Guys, once you get the hang of it, it's easy. Even if you don't get the hang of it, you'll get to it. But let me know that you didn't get. We'll do it together. Srishti, correct. Vibha, why Vibha? Why do you think so, Vibha? Correct, Sanshray. Vibha, why do you think so? Right. Last year, correct. Okay. Do you want to stop here? I can continue composition next class, but please do this and come. Okay, I'll make sure I post some homework on this. Definitely do this and come. Any questions for me? We just covered even odd functions, both graphically and algebraically. Given any function, you should be able to do. Okay, but I will add in a couple of harder problems. Try that at home. Suppose if I give you f of x is an even function, g of x is an odd function, I will ask you, hey, f of x times g of x, is it even or odd? That's the tricky part. Here, if it is even, right, then f of x will be equal to f of minus x, correct? Now, g of x is odd means I'm asking this function is even or odd. Name that function as h of x. Okay. Now, what is h of minus x? Wherever I see x, I have to substitute minus x, right? See? I substituted. But f of minus x is an even function. It's the same as f of x. But g of x is odd. So this would be a negative of g of x. So now my new function, when I fed in the negative input, it became the negation of this. So this function is what, even or odd? Anybody?
Odd.
Odd. Why, guys? I fed in negative inputs. This is a harder stuff, okay? I fed in negative inputs. This became negative input. I fed in negative inputs for my function. H of x is my function. But I know f of x is even. So f of minus x can be substituted as f of x. But g of x is odd. So g of x, here we have g of minus x, right? I cannot substitute it as g of x, but I have to substitute it as minus of g of x. So finally, when I fed a negative input, the function became negative of f of x g of x. So it is odd. Did you understand this? I'm going to add in one or two problems in this. Okay, the last few. Okay, any questions for me? If you didn't understand, you have to bring it back. That's all. Okay. See you all next week. Have a nice summer week.
Bye, Miss Priya.
Bye, guys.
That was Priya.
Bye, guys.
Miss Priya.
Bye, guys.